Bismillahirrahmanirrahim. So in the last class, if you remember, we discussed about work done against force of gravity, and we saw that the work done against force of gravity is directly proportional to the displacement. Okay, W is proportional to H. Then I told you to go through this extended activity, that is work done by gravitational force. So did you go through? Do you have any doubt?
No, sir.
Okay, mashallah. So if anybody have any doubt, then this is the time to let me know so that I can discuss about it, or else I'm going to talk about energy. Anybody
No, sir.
ask anything? Okay, the calculation is simple, right? Because we are repeating the same integration, we are using the same formula again and again, right? So I think you got it. Okay. Now, so inshallah, let us start energy. Okay, so what is energy? Can anybody tell me? You already know about it from SSC level, right?
Energy is the ability of work
Very
to
good.
do work.
Ability to do any work is energy. Okay, if you have the ability to do any work, I will say that you have energy. Now we know that the amount of work is equal to amount of energy. So that is why if you say that I can do 20 joule of work, then I can say you have 20 joule of energy, because the amount of energy you have, that to amount you can only convert into work, right? Work and energy, they both are equal. Okay, always remember this thing. If you remember, I used to ask one question when you were in SSC level, that if there are two-person, okay, one person is doing 20 joule of work in maybe 1 hour, and another person is doing 20 joule of work in 2 hours. So who has the higher energy? I want to know it from Nurnabi. Nurnabi, who do you think have the higher energy?
Both of them are having same energy.
Both of them are having same energy. Why do you think so? Why? Acha, Saiful, can you tell me the reason that why they both have the, at first tell me, do you agree with Nurnavi that both have the same energy, or you think that someone has higher energy?
Sir, what was the question, sir? I forgot. I mean, I
What's the
didn't.
question? Okay, I will repeat it for you, no problem. Two-person, one person is doing 20 joule of work in 1 hour, and another person is doing same 20 joule of work, but he is taking 2 hours. So who has higher energy in between them?
Sir, both of them having same energy because both of them has completed the work. I guess.
Okay, very good.
I mean,
So
they are
both
doing
of
the same.
them have completed the work. That means both of them did same amount of work, right? 20 joule. So both of them have same energy. We will not worry about how much time they took. Okay, if we are considering energy or work, we will consider the time when we are calculating the power. Okay, so the person who will take less amount of time, okay, যে কম সময় বেশি কাজ করে ফেলতে পারবে, তাকে আমরা বলবো পাওয়ার বেশি। But energy, both of them have same. If same amount of work is one person, if one person is doing in 1 day and another person is taking 1 year, no problem. Both of them, if they do the same amount of work, they have the same energy, no matter how much time they take. Okay, please always remember, energy and work does not depend on time. Power is something that is calculated depending on time. Okay, remember always. So the ability to do work is energy. If you can do 20 joule of work, you have 20 joule of energy. Or in reverse direction, we can say that if you have 50 joule of energy, you can do 50 joule of work. Okay, acha. Now the dimension for work and energy are same. Okay, that is ml square T inverse 2. Okay, this is the dimension for energy, and unit is same as joule. Okay, same as work. Both of work and energy both have same unit. Now if you take a look, there is a topic of kilowatt hour at the end of the page number 298. Kilowatt hour, it is written like this, mostly without a hyphen, kilowatt hour. Okay, it is written like this. Now looking at this, you might feel that this is the unit of power because watt is there, right? We know that watt is the unit of power. So kilowatt hour, it might sound like that it is the unit of power, but in fact it is the unit of energy. This is a unit of energy. Okay, very important for MCQ. Kilowatt hour is the unit of, either you can write watt or you can write energy. Okay, Acha. So how it is a unit of energy? Let us take a look. Okay, kilowatt. What kilowatt is unit of what?
Power.
Power. Very good. Power into hour. Hour is the unit of
Time.
time. So power into time. What we will get? We will get to know this from the
Energy.
definition of power. We know that the rate of work done is power, or we can say work divided by time is equal to power. We can write it here work, or we can write energy transferred. We can write any one of them. Okay, work done or energy transferred divided by time is equal to power. Now if I put it will be like this: P equal to W by T. So if you cross multiply it, then it will be P into T is equal to W. So we get to know that P into T is equal to W. Here I have multiplied power and time. So I should be getting watt, and watt and energy is the same thing. So we can say that kilowatt hour, this is the unit of energy or work. Okay. Always remember work done is equal to energy transfer. Okay. Whatever work you will do, that amount of energy will be lost from your body. Okay, it will be transferred to the body on which you have done the work. Like if I lift this body to a certain height, then what will happen? I have done some work on this, right? I have applied some force on it and caused some displacement in the direction of force. So definitely I have done some work, and while doing this work I have lost a certain amount of energy. So from the conservation law of energy, we know that energy can neither be destroyed nor be created. It can only be transformed from one form to another. Now, while it was in our body, it was mechanical energy. And when we did some work, we lost that mechanical energy, and it got transferred into this body and stored at potential energy. Okay, so you see change transforming from one form to another. Okay, so work done, the amount of work done by me is the amount of energy transferred from this body to this body. Okay, I hope you understood. Acha. Now, in SSC level, what we studied is two types of mechanical energy. Primarily, we can divide energy into so many categories: electrical energy, chemical energy, mechanical energy, renewable energy. Many types of energies are there. Okay, so specifically we focus on mechanical energy. Okay, and we subcategorize it into two categories. Okay, what are those two categories? Can anybody tell me?
Kinetic energy, potential energy.
Very good. Kinetic energy or and potential energy. Okay. So kinetic energy, when I can say that a certain body has kinetic energy?
When a body moves,
When a body is in
like
motion. Very good. Moves, right? Okay. So when a body is in motion, we can say that it has kinetic energy. And when a body is at a certain height from the ground, okay, that time we can say it has some potential energy stored in it while it is not moving. Okay. Achha, theek hai. Now, so the ability of doing work of a moving body due to its motion is called kinetic energy. Okay, so the definition contains energy and kinetic both. Okay, see, the ability to do work, that is energy, due to its motion, due to our body's motion, that is kinetic. Okay, being in motion is kinetic. So this is the definition of kinetic energy. Now we already know that kinetic energy is equal to half mv square, right? Today we are going to reprove it, okay, using calculus, inshallah. Okay, let us see. So we have to prove that kinetic energy is equal to half mv square. We know that work done is equal to energy, right? So if I can calculate the work done to make this body come into motion, then I can say that that is the amount of energy or kinetic energy within in the body. Okay, so if I want to calculate the work done, I can write W is equal to what? F dx. Definitely, as I'm talking about small amount of displacement, the work done will be small. So to get the total work done, I will integrate it. Okay, so integration and differentiation, they will balance each other, and W will equal to, it will become integration F dx. Okay, so as the body is still moving, you cannot actually fix any initial point and final point, right? Initial point, okay, you might be able to fix, but there is no final point. So we will not be able to put any value or any limit in case of displacement, okay? But we can put a limit up to for a velocity. For velocity, okay, previously the velocity was 0. Now it has achieved a certain amount of velocity. So as it has achieved some velocity or gained some velocity, it has gained some kinetic energy. So how much velocity it is gaining, depending on that, I can say that this amount of kinetic energy it has gained. Remember, depending on the velocity. Okay, always remember. So I need to change this. Dx, I cannot keep it here because in respect of x, I cannot actually differentiate it. So if I want to change it, how I can change? If you see, this F is equal to, I can write ma, right? Then again, a is acceleration, right? So acceleration is what? The rate of change of velocity with respect to time. Correct or not? Acceleration is the rate of change of velocity with respect to time. Achha. Then I can rewrite it in this way, dx into dx by dt. If you notice, I did not actually make any kind of change, okay, in the equation. Dx and dx, if they get cancelled, it will become dv by dt again, right? So I can write it in this way. There is no harm in writing in this way, but this will serve my purpose. M will be here. Now dx by dt, what is this? The rate of change of displacement, that is velocity. So it will become velocity, and dv dx will be here. Okay, now I will replace the value of f. This value of f I have got here, I will replace it here. Let us see what happens. F will be replaced by mv dv dx into dx. Can you see the writings on the board clearly?
Yes.
Next opinions. Okay, so it will be dx. Okay, so this dx and this dx, they will actually cancel each other. So the equation will become mv dv. This is the equation. Now you can see that with d we have v. So now we can put the limit for velocity. So the lower limit, it is going to be 0 when the v is equal to 0, and when the v is equal to v. Okay, from 0 it became v. Acha. Now, out of this m and v, one will come out of the integration. Can you tell me which one and why?
M.
Why?
The constant.
Constant.
Mass is constant for a body.
Same body, then the mass will remain constant. So here W will be equal to, then m will come out of the integration. It will be v dv, and it will be v equal to 0 to v equal to v. So v dv, again we will apply the same formula. If you remember, I'm not writing the formula today. Okay, I hope by now you have almost memorized. Now v to the power 1 we have here, right? If there is no power, we consider the power is 1. So what we write in the numerator, we add 1 with the power, right? Whatever the power is there, if you remember, x to the power n plus 1, n is the power 1 that we have here, and we add that, add 1 with that, and whatever the power is, we write it in the denominator also, and then here it will go the upper limit and lower limit. Then it will be v square divided by 2, okay, for limit and lower limit. So from here, what I can write, m into At first, this V will be replaced by this V here. So it will be V square by 2 minus, now this V will be replaced by this 0. So 0 square divided by 2. So 0 square divided by 2 is actually 0, right? So I will subtract 0. So subtracting 0 actually doesn't give us anything. Okay, that means the amount remains same. So m into v square by 2, can I write it half mv square? Can I write it half mv square?
Yes.
So we
Yes.
have proved the work done is equal to half mv square, and we know that the amount of work done is equal to kinetic energy stored in the body. So we can say the kinetic energy stored in the body is half mv square. So we have proved it using calculus. Is there any doubt in any line?
No.
Okay, good. Now we will try to establish a relationship between momentum and kinetic energy. Okay, momentum and kinetic energy. What is momentum? Morshed?
Mass into
Velocity, mass into velocity.
Morshed is not there. Okay, Shiham, what is momentum?
Product of mass and velocity.
Very good. Product of mass and velocity. Okay. Now check. We have mv square here and 2 here. If I divide one m here, I have to multiply another m here, right? Can I write it in this way? Okay, m square by m, it will give me m only, right? So 1 by 2m, I can write this m square v square as mv whole square. Now mass into velocity, that gives us the momentum. So it becomes p square divided by 2m. So this is the equation that relates the kinetic energy with the momentum. Did you understand the derivation? Is there any doubt? Did you understand what I did here?
So momentum সাথে রিলেশনটা কি কাইনেটিক এনার্জি
এই যে সেটাই তো আমি দেখাইলাম না।
মাস ইনটু ভেলোসিটি
মোমেন্টামের স্কয়ারকে তুমি যদি টুয়াইস অফ দা মাস দিয়ে ডিভাইড করো তাহলে তুমি কাইনেটিক এনার্জি পাবা। অর তুমি যদি এখান থেকে মোমেন্টামের একটা ইকুয়েশন বের করতে চাও তাহলে কিভাবে বের করতে পারবা? p square is equal to, you will multiply 2m with ek. Okay, so 2m into ek, then p is equal to, you can write root over 2m ek. Okay, so if you know the mass, you know the kinetic energy, then you can find out the momentum. Any doubt?
No.
Okay, so these are the equation. Actually you have to keep it in your mind. Okay, now understanding the derivation is important because sometimes we are human being and the equation just slips out our mind. Okay, so without any without wasting any time in the exam, you can just do the derivation. It's just 3-4 line derivation. Derive this equation and then use. Okay, then you will be sure that you have written the right equation. Okay, so that is why understanding the derivation is very important, so that we can develop it anytime we want. That's it. Okay. The next topic is something that I have already discussed while solving some creative problem of the last chapter. Do you remember work energy theorem? I told you that this is a topic that we're going to study in the next chapter. Okay, and this is here. Do you remember or not? Yes or no? At least one answer you have to give.
No,
You don't remember that we discussed this work energy theorem?
no, sir. I need to watch the video again.
Okay. As you don't remember, I have to discuss it again. Okay, I will discuss, no problem. I was actually gonna discuss anyway because Many of you missed that class. Okay. So work energy theorem, what does it say? Let us go through the statement. The work done on a body by an applied force is equal to the change of its energy. Okay. So if a body was already in motion, then it had a certain amount of kinetic energy. Now you applied some force on it and caused some displacement. That means you did some work on the body. So while doing the work, definitely as you are doing the work, you will lose some energy, and that energy will be stored in the body, and the body's kinetic energy will be increased. How we will understand that the body's kinetic energy has increased? By looking at the velocity of the body. If the velocity of the body, if you see that it has increased, that means you have transferred it some energy. Using that energy, he increased his velocity. So whenever we are talking about energy that is related to velocity, it is kinetic energy. So we will say that there is an increase of kinetic energy. So here they want to say that increase of kinetic energy is equal to the work done by you. Okay, this is what they are saying. The increase in energy, or it will not be always an increase, it might be decrease also. That is why it is generally termed as change of energy. So change of energy is equal to work done. This is the work energy theorem. I will tell you again. The change of energy is equal to work done. Change of energy is equal to work done. Previously, there will be a certain amount of energy, and after you did some work, there will be a certain amount of energy. So the difference between them, this increase has been caused due to the work done by you. So the work done will be equal to the change of this energy. Okay. Acha. Now let us take a look at the deduction. Okay, suppose a constant force F acts on a body of mass m moving with a velocity v naught. Due to this body, see the body is already moving, okay, with the velocity v naught. The force that is acting on the body is F. The mass of the body is m. Okay. Due to this, the body attains a velocity v and covers a distance x. Now, already the body was moving with this velocity, but now some new force is acting. We already know that whenever there is some force applied, there will be change of velocity, right? We know this because F is equal to ma, right? So if you apply some force, so what will happen? Mass will not be changed. There will be some acceleration, right? There will be some acceleration. Now, what is acceleration? The rate of change of velocity. So whenever you apply some force, there is change of velocity, and that is called acceleration. Okay. So now as the force is acting, the velocity will change, and let us say the velocity has become v. Initially it was v naught, some force has been applied, and the velocity has become v. Okay, and covers a distance x in the direction of applied force. If I am saying that I have done some work, definitely some force applied has to be there, and some displacement has to be caused due to this force. Okay, so x is the displacement. Hence the work done by the force. The work done by the force will be force into displacement, that is W is equal to Fx, right? If a is the acceleration of the body, then according to Newton's second law, yes, we already know that F is equal to ma. So F is equal to ma. If I replace the value of F in this equation, it will become F, I will replace by ma. So it will be max. W is equal to max. Anybody have any doubt till now?
No.
Okay. We know this equation, right? V square equal to U square plus 2as. Now in HSC level, we have actually replaced U by V naught. Okay, V square equal to V naught square plus 2a. S is the displacement. S represents displacement. But what is the displacement we have considered here? X. So S will be replaced by X. Okay. So if I want, I can find out a value of AX. See, we have AX here. So let us try to find out a value of AX and try to plug it back over there. So V naught square will be changing the side. So it will become minus, and it will be 2AX. Now, as I want the value of AX, I will change the side of this 2. Then it will be V square minus V naught square divided by 2. So Ax, I have found this value. I will plug it back into this equation. So this will become m into this Ax will be replaced by v square by v naught square divided by 2. So then half this one I will write it at first, then m will be multiplied with them. It will be mv square minus mv naught square. So then if half is also multiplied with them, half mv square minus half mv naught square. Now what does this tell you? What is half mv naught square?
Kinetic energy.
Kinetic
Kinetic energy, but what initial or final?
initial kinetic
Initial
Initial.
kinetic energy, right? So that is
Yes.
initial kinetic energy, and this is final velocity v, right? So as a result, it will be final kinetic energy. So final kinetic energy minus initial kinetic energy. Can I write it that this is equal to change of kinetic energy? Can I write it?
Yes.
So change of
Yes.
kinetic
Yes.
energy. So I have shown that W, that is work done, is equal to change of kinetic energy. Do you have any doubt now? Understood?
Yes, sir.
Okay. So this is the
Yes.
general proof. Okay. We might be asked to prove it using calculus. So next I'm going to show you the proof of this using calculus. Okay. This is the general proof. In the question, it might be mentioned that prove the work energy theorem using calculus, with the help of calculus. So that time, how you can do, I will show that now, inshallah. So W is equal to, as I said, it is force into displacement, and force can be replaced by ma, so it is max. Now A is equal to dv by dt. Okay, the rate of change of velocity with respect to time. Again, this dv, I can this expression I can write it in this way. See, dx and dx, they are cancelling each other, and it will become dv by dt again. So here dx by dt, it will become v, because the rate of change of displacement is v, and then dv dx will be there. So dv dx. Okay, so a can be replaced by this. Okay, so in this equation, let us say we have considered this one is equation 1. So equation 1 will become now w is equal to m is there, x is there. A will be replaced by um, oh, okay, I'm sorry, I forgot that whenever we are using calculus, at first we have to consider the displacement to be a smaller displacement, that is dx. Okay, and for this small amount of displacement, the work done will be dw. Now I want to find out the total amount of work, so I will just integrate. So integration, differentiation, they will balance each other, and it will become w, and integration sign will still be there. So then when I replace the values here, you will see that m I have written here, a will be replaced by this v into dv dx, and dx is there, this dx is here. Okay, a is the value that I have replaced. So again, dx and dx, they will cancel each other. Okay, so it will be m v dv. Now this m will come out of the integration because it is constant. Now as with d we have v, right? So we can put the limit of v here. As I already told you, the initial velocity was what? V naught, and the final velocity was v. That is the upper limit, lower limit, and upper limit, right? So then you can do the integration. So it will give you, as I already showed you a little bit ago, the same thing I have done a little bit ago, v square by 2. So I directly wrote it. The power is 1, 1 plus 1 is 2, and the denominator will also be 2. And the lower limit will be placed here, and upper limit is here. Okay. So half m. Then what can I হাফটা তো এখানে আসার কথা না, এখানে হাফটা বের করে আনতে হবে। সো এই হাফটাকে যে 1/2 যেটা, সেটা আমি যদি সামনে লিখি, দেন m into this v will be replaced by v first, v square minus this v will be replaced by v naught square then. So v square minus v naught square. Okay, so half m, if I multiply, if I withdraw the bracket, it will become half mv square minus half m v naught square. See, the final kinetic energy minus the initial kinetic energy, which is equal to what we have proved using the calculus. Anybody have any doubt in the derivation? Nobody? Okay, so kindly go through this topic and this derivation, and if you come across any doubt while revising at home, let me know through WhatsApp so that I can discuss about that a little bit in the next class, inshallah. Okay, I'm sorry that I started the class a little late today, and that is why I took 3 minutes more. Okay, hope you don't mind. Thank you very much for joining. Before I end the class, anybody wants to ask any question?
No.
No. Okay, so you understood. Thank you very much. Assalamu alaikum warahmatullahi wabarakatuh. See you tomorrow, inshallah.